I'm Anil Kumar, and we'll try to understand in this video how can we combine exponential functions with trigonometric functions. In this example, we have f of x equals to 2 to the power of minus x over pi and g of x is equal to 2 times cos of 4 of x. And we'll try to do these operations in the domain 0 to 4 pi. What I've done is I've already got the graphs here since it is easy to understand from the graph, and we'll in this video understand how to sketch these graphs. Okay, now if you're looking for the exponential function 2 to the power of minus x over pi, this should be kind of exponential decay, right? So we are looking for a function which is like this. So that is the function whose value will start with anything to the power of 0 is 1. So the maximum value starting for this function is going to be 1. And if I write 4 pi, then it will be 2 to the power of minus 4, right? So 1 over 16 will be this value, correct? So that value, if this is 4 pi, will be 1 over 2 to the power of minus 4, correct? So that is 1 over 2 times 2, 4, 4 times 2, 8, 16, right? So 16, 1 over 16, right? So that is kind of the very first function which we have. And now let us see what is g of 2 cosine 4x. So let's sketch this function also. G of 2 cosine 4x. Now cos of 4x means we have 4 periods or 4 cycles of cosine function within 2 pi. So in 4 pi we will have 8 cycles, correct? So I will not draw 8 cycles, but you know what we are trying to do. And the amplitude here is 2. So basically cos starts from the maximum. So we basically will have cosine function which will have maximum of 2, minimum of minus 2. So it could be drawn like this, right? So like this it could be drawn, right? Now the idea here is we will have within a time period of 4, so one will have 4 cycles within 2 pi, right? So within 4 pi we are going to have 8 cycles. So starting from here 1, 2, 3, at least I should draw one more. Okay, so that means that much is 2 pi for us. So up to 2 pi, 1 cycle, 2 cycle, 3 cycle, 4 cycle. So cos of 4x will have 4 cycles within 0 to 2 pi, maximum and minimum being 2 and minus 2. Right, so that is, these are our functions, and of course I've drawn half of this. Now we will see how to combine these functions. When we say combination, we're trying to add, subtract, multiply or divide. Now addition, subtraction is a similar operation, so I've just taken one of them and addition this time. So if you add 2 and 1, you get the value of 3, and so the combined function starts with 3. Now as you go further, you'll find that the maximum values will decrease as per this function. You see, as per the exponential function shown here, correct? So it's kind of superposition of these one over the other. So that is what combination really is. So whenever you add and subtract, you have the whole band within the superpositioned on this particular graph. You see, you could take that in the center and this wave rides over it. So that is how you get your result, right? If you're doing f of x minus g of x, then consider minus 2x. That means the maximum will start from here, right? So instead of starting from there, if you start from minus 3, it becomes minus g of x. I hope you get the point. But it is going to look very similar, just as you see here, right? And you will note that we have from here 1, 2, 3, 4, 5, 6, 7, 8 cycles in 4 pi, and that is kind of critical to understand. The other combination for us is the product. That means we'll multiply exponential and the trigonometric function. If you multiply 2 by 1, you get 2. So the maximum is 2 in this particular case. Okay. And as you gradually go, the graph actually decreases, as you can see here, correct? So that is the kind of graph which you are going to get when you combine an exponential function with a trigonometric function. Since it is a cosine graph, it starts with the maximum. If I would have used a sine graph, we would have started from 0, right? So that could be a test problem. So take care of that. So these are very fine points which you need to understand when you are solving this question in your test, right? So these graphs help you. So go through them once again. Okay, now the last one here is f of x divided by g of x. So when I divide, basically I'm multiplying reciprocal of cos of 4x, which is secant, right? So that is what it is. So secant, as you know, is a function which is reciprocal of this. So it will have vertical asymptotes. Since the 0, 1 over 0 is not defined, so therefore you see these types of graphs. Now the domain has no problem here, but the domain is restricted. All these zeros which are at pi by 2, 3 pi by 2, 5 pi by 2, right, in normal function will now be the vertical asymptotes. And of course those pi by 2's will be getting divided by 4. So instead of pi by 2, 3 pi by 2, I should say 2n plus 1 pi by 2. These are going to get divided by 4, so it will be 8, right? So for secant 4x. So at these points, we are going to have vertical asymptotes. So that is what you see here, those vertical asymptotes, right? And the range for cosecant function is between, in this case it is 2 times, so it is between 2 and minus 2. But if I take secant function, then it is greater than 1, right? So when you multiply this by 2, when you divide this by 2, because 2 comes in the denominator, so it has to be greater than half, and therefore that is what you find, that when you multiply half with 1, it starts with 0.5. So 0.5 is the starting point when you divide f of x by g of x, and that is how you get your graph. I hope the concept is kind of clear to you. From these graphs, you can now sketch the combination of exponential and trigonometric functions. So the whole idea was here to give you an exposure of what happens when we combine exponential with trigonometric functions. So these are the examples for exponential and cosine function. You can try it for sine function. The difference will be that the sine function starts with 0, right? And the cosine function starts from maximum. So the starting point will be different, but the nature of the graph will be exactly same. I hope that helps. Thank you and all the best.